right, so our last example in 3.1, we're going to create a little scatter plot and analyze that graph. So here's a little Snapple fact lid. I actually had that Snapple fact one time. It said that the number of times a cricket chirps in 15 seconds plus 37 will give you the current air temperature. So the first thing I want us to do, you kind of see a blank. It says this can be translated into the linear equation, and then that is for us to do. So the number of times that a cricket chirps in 15 seconds. So I'm going to let the number of times that a cricket chirps in 15 seconds, I'm going to let that equal C. So let's let C equal the number of chirps in 15 seconds. So that's what we start with, the number of chirps in 15 seconds. All right, well then, of course, we just have addition here. So we just have, plus. So plus, we can certainly do that. So this is going to be our plus, plus. And then 37, so plus 37. So 37 there. So plus our 37 is going to give you, so will give you is just kind of like the is, right? So will give you is going to be the equivalent of our is equal to, and then the current air temperature. So our current air temperature, so let's let that equal another variable here. So the current air temperature, we're going to let that equal T. So let's let T equal that current air temperature. So that's going to equal T. All right, so there is my equation. So probably more traditional to write that equation as, so let's maybe kind of off to the side here, write that as just T equals C plus 37. Okay, that's probably a little more common of an order. Okay, now that we have our equation, part A. Use this equation to generate a list of ordered pairs. Okay, so let's do that down here. So this will be our part A. So again, keep in mind T is equal to C plus 37. And so we're going to create what normally is like a little XY table of values. Here it's going to be C and T. So a little CT table of ordered pairs. Now let's think about this. C is cricket chirps in 15 seconds, so it doesn't make sense to do anything with negatives. So in practical terms of this problem, it only makes sense to start with 0. And all we're really doing here is this arithmetic. We're subbing in 0, and so we're going to get that T is equal to 0 plus 37, so 0 is equal to 37. And so on. So what if I have one cricket chirp in 15 seconds? So if my C is equal to 15, I would have T equals 15. Oh, why did I just say 15? That was weird. If T is equal to 1, then we're going to have 1 plus 37, and so that's going to give us our 38. And so on. This becomes pretty easy arithmetic, right? So if we now sub in 2, we just have our 2 plus 37. So this would estimate our temperature to be at 39. So 2 plus 37 is 39. So that's what we would have here. And so on. I think we can kind of see what's happening. We're just going up by 1. Let's say we jump ahead to maybe a value of 10. So let's go a little further down the line. So we sub in 10 for C, and then 10 plus 37 is going to give us 47. Okay, so that's a good set of ordered pairs there. Now part B is just going to ask us to plot these values. So I think as we look, we kind of see that we can have this nice little first quadrant here. And when we think about the input values, what's normally the X values, or in this case the C values that I have subbed in, I think just going up by increments of 1 really does make sense in practical terms of the problem here. If I was, looking at something else, I might count up by different increments. In fact, we may actually count up by different increments, and probably will here when we look at the vertical axis. So there's my horizontal axis. Now for my vertical axis, notice my first value at 0 is going to start at 37. And then by 10, I need to be up at 47. So, I think if we maybe instead of counting up by 1s, if maybe we counted up by 2s. So I think if we count up by 2s, that might be just a little bit better here. And sometimes it takes a little while to, if we're, doing a sketch like this by hand, it might take a little bit to find kind of the right increments so we can get a decent enough sketch on our coordinate plane here. So basically, since I'm counting up by 2s, I'm just kind of counting out here every increment of 5 is going to then be an increase of 10. All right, so now let's go ahead and plot these points that we just found on our coordinate plane. All right, so at 0, I'm at 37. So 32, 4, 6, 37 would be right here, halfway between 36 and 38. Okay, and then at 1, I'm actually right there at 38. At 2, I'm at 39. I can continue this idea. At 3, I'd be at 40. So let's kind of visualize what's happening here. For each value that I'm going to the right one, I am actually going up by 1. So I'm going up 1 over 1, but because my increments on the y-axis are going up by 2, graphically it's like going up a half over 1. So graphically it's like going, up a half over 1. Or if I want to start to skip some values here, I could show it as going up 1 over 2. If I wanted to just extend out some more points on this, what's going to be pretty clearly here a linear graph. So this is going to become our focus in the next number of sections here. We're going to focus in on lines. So lines are going to have what you're seeing here, this constant pitch or this constant rate of change. All right, so there's my graph. And then the last question here says, looking at the scatter plot, how many chirps in 15 seconds would you need to hear in order to conclude that the temperature is, oh, I don't want 90 degrees. I meant to change that. I must be working off a slightly older file. I thought I had changed that. So 90 degrees is off of my graph. So do me a favor. If I want us to use the graph, which is what I said, let's change that to 60 degrees if you would be so kind. So let's take a look at that here. So if I'm looking at 60 degrees, so I'm up here, and so looking at that 60, I would be just kind of going over on that 60 line, and I get right here, and then I just want to take that down and look at what X value that would be. And so this would be at 23. So just using the graph, I would conclude that this would be 23 chirps in 15 seconds. Now, of course, we also could have used the equation. We could have subbed in 15 for the t and solved it for the c. So, but here I said to use the scatter plot. All right, so we're going to start to really focus in on this type of relationship in the next couple of sections, which is lines.